Hello, this is checkpoint 4.35. We have a rectangle that is supposed to be inscribed inside of this unit circle. What's the domain of consideration? And what should the dimensions of the rectangle be to maximize its area? So we want to draw a rectangle in here. And the rectangle can be of any shape, but inscribed means the corners have to be touching the circle. And to find the area of the rectangle, we need base times height. If we call this value x here, we can kind of look at the base as this x value here is just half of the base, so the base would be 2x. And there's going to be a y value here, and the base is going to be 2, or the length is going to be 2y. And so the area that we're looking for is 2x times 2y. And this is the relationship between them. So area, let's call this area A, is equal to 2x times 2y, or 4xy. Now I want to be able to write my value of y or x, or I want my area to be a function of just one variable. So I think I might be interested in solving for y here. And if we solve for y, this is going to be the square root of 1 minus x squared. And, you know, I would take the positive side because we're looking at lengths, and our length should be positive. And so my area now, as a function of just one variable x, will be 4x times the square root of 1 minus x squared. Now the domain, so this is our area function that we're trying to maximize. Now our domain of consideration would be, what values of x can I put in here? I can't put anything less than 0. I shouldn't, because my x value is some distance over here. And if x was equal to 0, then the area is going to be 0. And I can go as far as 1, but I can't go past 1. So my x is limited to go between 0 and 1. So that's my domain consideration. All right. Now, if we're actually going to try to solve for this, the problem doesn't ask us to do that, but I think we should go ahead and try to solve for this anyways. Then we're trying to maximize the area, maximize A. So in order to do that, we'll go ahead and do our analysis for finding max and mins within this interval. And in this interval, we're going to say the derivative is going to equal to, I think I can't get out of a product rule here, so let's do the product rule. It's the first derivative of the first times the second, and I'm going to put this in parentheses, 1 minus x squared to the 1/2 power, plus the first, which is 4x, times the derivative of the second. So this is going to be a 1/2, 1 minus x squared to the negative 1/2 power, and then I'll squeeze in here a small amount. That's the derivative of the inside. That's a negative 2x. Okay, so the 2's are going to cancel, I think, here, and let's write this. Did my derivative wrong? Nope, I think it's okay. So we have 4 times the square root of 1 minus x squared in the numerator, and then we have a 4, an x, and an x with a negative, so let's call this a negative 4x squared divided by the square root of 1 minus x squared in the denominator. Okay. I think we can combine this by having common denominators, and the common denominator would be 1 minus x squared under a square root, which means I would multiply this by itself, and that would give me a 4 times 1 minus x squared to the first power minus 4x squared. All right, now we're going to want to set this equal to 0 because that's what we do. We set our derivatives equal to 0. And when we do that, the denominator, as long as we're not including 0 or not including 1, the denominator would be okay, and we don't have to worry about that. So let's just figure out what happens in the numerator. And I'm going to take a step where I'm going to distribute. I have a 4 minus 4x squared minus 4x squared equal to 0. And then this will give me 4 minus 8x squared is equal to 0. So x, if we bring the 4 over and divide by 2, or divide by 8, we're going to get a 1/2, and then the 1/2 in the denominator, taking the square root. So it's 1 over root 2 or root 2 over 2. Could have put plus and minus here, but you know we're going to want the positive value anyways, so we'll keep it positive, and this would be the x value that you would have. If you put this into the y value, so y, when we put in the x value of 1 over root 2 quantity squared, this will give me 1 minus 1/2, which is 1/2 under square root, so it's also 1 over root 2. So it'll be the same dimensions. So it seems like that the rectangle should have dimensions of x by 2x by 2y. So it'll be 2 root 2 by 2 root 2. I think if you find common denominators, or not common denominators, but if you rationalize the denominator, you'll just have a root 2. So let's write this a little bit neater. Let's first establish the fact that 2 times 1 over root 2 is going to be equal to 2 root 2 over root 2, or over 2, which is just going to be root 2. There we go. So the dimensions of your rectangle should have dimensions root 2 by root 2, which is a square that would fit in this box, or in the square that would fit in this circular unit circle. Okay, I hope that helps.